Hello everyone. Today we are going to be going through the grade 11 mathematics paper 1 paper or exam paper that was written during the May-June session. Jumping right in without wasting any time, we are going to begin with question 1.1.1. Solve for x. My favorite. It's the easiest. We are told that x squared minus 7x plus 12 is equals to 0. Now, the first thing that we need to ask ourselves is what factors of 1 and 12, the positive 12, can give us a negative 7. Now, from inspection, clearly that tells you you need a minus 3 and a minus 4. Those will be our factors, thus we will put them into our brackets. X minus 4, x minus 3 equals to 0. We finally have that x is equals to 4 or x is equals to 3. For our second question, 1.1.2, we are given that x into 3x plus 5 is equals to 1 to 2 decimal places. Immediately, what this 2 decimal places tells you is that you are going to be playing with the quadratic formula, right? So what you're going to do, the first thing that you're going to do is we are going to write this equation in standard form. Now, what do I mean about standard form? I mean something like this, right? And writing that in standard form will require us to multiply out the brackets such that we have 3x squared plus 5x being equal to 1. And then transposing our 1 by essentially subtracting it on both sides, because remember, what you do on the left you must also do on the right. We thus have 3x squared plus 5x minus 1 is equals to 0, right? Please do not be confused here. This is not a x to the power of minus 1. I am just demonstrating that we have to subtract a 1 in order to get what we want. So please do not confuse that with a 5x to the power minus 1. That should be fine. That should remove any confusion. Wonderful. So now, since we have standard form, immediately, because our question told us that we need to correct to 2 decimal places, we summon the power of quadratic. In our quadratic formula, what does it say? It tells us that x is given by the negative of b plus minus the square root of b squared minus 4ac all over 2 of a. We already know that because of our standard form ax squared plus bx plus c equal to 0, we know that a equals to 1, b equals to 5, and c equals to minus 1. Plugging that into our formula tells us that x is equal to minus into 5 plus or minus the square root of 5 squared minus 4 into 1 into, is that minus 1? Yes, and this should be a 3. This should be a 3 because our a in this case is equal to 3. I apologize for the mistake, but it's not a train smash, easily fixable mistake. Glad we caught that really quick. Into 2 multiplied by a, which is 3. Now this is going to give us minus 5 plus minus 27 minus what's 4 into 25, sorry, 25 minus 4 into 3 minus negative 4 into 3. 4 into 3 is 12, so 25 plus 12 will give us a positive 37 divided by 6, right? Thus our x is equal to 0.18, or x is equal to 1.85. Wonderful. Moving on to question 1.1.2, sorry, 1.1.3, which is an inequality. Our inequality states that x squared must, I didn't write down the question number. 1.1.3, x squared must be less than minus 2x plus 15, right? Immediately we know that we need to write this in standard form, and when we write in standard form, we add 2x and we subtract 15, add 2x, subtract 15, such that x squared plus 2x minus 15, sorry, is less than 0. Now this is our function f at x. If we are going to write our function in standard form, it means we need to get that equal sign so that we can get the roots of our equation, right? So now the roots of our equation, we're going to be looking for factors of negative 15 and 1 that could give us a positive 2. And what factors are those? Just looking at it, you can tell it's a 5 and a 3, but is it a positive 5? Is it a negative 5? Because this 2 is positive, it tells you that the bigger number must be positive. Thus, you have x minus 3, x plus 5 is equals to 0. But this step comes after writing your inequality, x squared plus 2x minus 15, as an equation, because you're writing it in standard form, and the way to solve this is by using an equation. Now, x will be equal to 0, or x will be equal to minus 5. So the fun part begins here. When you get to this stage, because you have two possible values, you have two roots, you have to determine which of these roots satisfy our condition. And if you look at it, our condition tells us that f at x must be less than 0. So what are we going to do? The first thing that we're going to do is we're going to highlight what these roots look like on our Cartesian plane. Our minus 5 will be this side, our 3 will be that side. The next thing you need to decide is whether your graph of f at x is going to be concave up, or is it going to be concave down? How do you decide which option to go with? Now, the way you decide is very, very, very easy. Remember that the standard form of our quadratic equation, ax squared plus bx plus c is equal to 0. In the standard form, the value of the value of a tells you about the concavity. The concavity is whether the graph is smiling up or smiling down, whether it has a smiley face or a frowny face. I don't know if you can call it smiling down, but yeah. So because in this situation our x is equal to a positive 1, it means our function will be concave up, or it will be smiling up essentially. Never mind the turning points and the intercepts. The only thing you need in this situation is the x-intercepts, which are your critical points. Now, the next thing that you need to do is you need to determine which part of the graph satisfies your, I had made a mistake there. You have to determine which part of the graph satisfies your condition, and your condition is that f at x must be less than 0. Now, when you look at your graph, you can immediately tell that when x is less than minus 5, our f at x is greater than 0. You see f at x is above the function. Here's the 0 line, is above the 0 line. It's above this 0 line right here. And you can also immediately see that when x is greater, let me use a different color. You can immediately see that when x is greater than 3, our function is still above the 0 line. However, when you look at between 5, that space between 5 and 3, where x is essentially sandwiched between them, I like to call it a sandwich because number, I like to call it a sandwich. So where x is sandwiched between x and x is sandwiched between minus 5 and minus 3, you see that our function is below the 0 line. It's below the y equals to 0 line. So then what does this tell us? This tells us that the only interval, or the only inequality that satisfies the condition that f at x is less than 0 is when minus 5x 3, when x is between minus 5 and 3. I hope that was clear. Moving on to the next question, 1.1.4, which is a surd question. Okay, it's given to us in surd form. 1.1.4, given to us in surd form, we have that the square root of 2, 1 minus x is equal to x minus 1. What you usually do for questions of this form, or for questions requiring you to solve for a variable within a square root, is you're going to want to get rid of the square root first. And the best way to get rid of a square root is to square. So what are we going to do? Square both sides, because remember, it's very important that what you do on the left is the same as what you do on the right. Now, after squaring, we find that 2 into 1 minus x is equal to x minus 1 multiplied by x minus 1. Using your FOIL method once again, you get that 2 minus 2x is equal to x squared minus x plus 1. Remember FOIL method. FOIL tells you first outer color, inner, and finally purple is fine, and finally last. That is what you need to do in order to expand on this bracket. Now that we've expanded, we can finally write it in its proper form, such that it's equals to x squared minus 2x plus 1. Now, taking the minus, you doing your basic algebra, you find that 0 is equal to x squared minus 1. 0 is equals to x squared minus 1, but I don't like the way this is sitting, so I'm going to write it in a way that's more visually pleasing, is equals to 0. It might seem like we have missed a step, but if you actually look at it, you will find that if you minus, you will find that if you will find that please excuse me that, you will find that if you minus 2 and add 2x on one side, and you also minus 2 and add 2x on the other side, you find that this 2x and this 2x cancel, and 1 minus 2 is equals to minus 1, which is why we reached that conclusion. Now, moving forward, we have that x squared minus 1 is equals to 0, which is quite clearly a perfect square, because remember that 1 squared is equals to 1, or 1 to the power of any number is equals to 1 itself. Thus, because of that, we can then write x squared minus 1 squared is equals to 0, and this is a difference of two squares, and a difference of two squares is then expanded upon as such: x minus 1, x plus 1, which is equal to 0. If you use the FOIL method to expand out these brackets, you will return right back there. So essentially, we haven't really done much. We just found a different representation for the question. Thus, you find that x minus 1 is equals to 0, or x plus 1 equals to 0, which tells you x is equals to 1, or x equals to minus 1. Now, what are we going to do? The thing that you're going to do now is you're going to take one of these solutions, right, or each of these solutions essentially, and plug it into your formula. Let's take x equals to minus 1, for instance. If we take x into minus 1, if we take x into minus 1 and plug it in here, we get that we get minus 1 squared, which is equals to this is minus 2 squared, it's 4, which is the right hand side. Now, the left hand side, however, you find sorry, this needs to go into the original formula. The original formula tells us that yes, it needs to go there. It needs to go into the original formula there instead of the one that is squared. So to confirm, what are we going to do? We're going to take x, we're gonna sub x equal to minus 1 into square root of 2x minus 1 is equals to x minus 1, right? So for the left hand side, you find that when you sub x to minus 1 is equal to square root of minus 4, which is an imaginary number. When you take the right hand side, you get minus 1, which is equals to minus 2. Now, clearly, the left hand side is not equal to the right hand side, which tells you that x cannot be equal to minus 1. Moving forward, we can then substitute x equals to 1 into 2x minus 1 equals to x minus 1, right? For the left hand side, you get, when you sub in, you get 2, 1 minus 1, which is 0. And then the right hand side, you then get 1 minus 1, which is 0. Here, the left hand side is equals to the right hand side. Therefore, your final conclusion, x must be equals to 1 and x cannot be equals to minus 1. So you have to keep in mind, that for questions where you have to solve for x and your x is under a surd or your x is under a square root, it's much better to start by squaring it first, working out what the roots are, and then substituting the roots back into the original equation in order to determine whether the right hand side is equal to the left hand side. For the case that the left hand side is not equal to the right hand side, it tells you that whatever critical point you inputted into the formula is not a critical point for that particular equation. It tells you that that is the incorrect solution. But if you find, however, that the left hand side is equal to the right hand side after subbing in a critical point, then that critical point is the true solution. I hope that made sense. Moving on to the simultaneous equation. The simultaneous equation tells us that 3 to the power x plus y is equals to 27, which is our first equation, and that x squared plus y squared is equals to 17, which is our second equation. Now, starting with the first equation, what do we do first? Now, looking at 27, we can already tell from exponents and the most basic exponents that we know that 3 to the power 3 is equals to 27. Therefore, we can thus write 3 to the power x plus y being equals to 3 to the power 3. Moving on, laws of exponents tell us that if you have a situation where a to the power x is equals to a to the power n, then you can just equate exponents. Using this rule, we can then write x plus y is equals to 3, where x will then be equals to 3 minus y. We name this equation 3. And what do we do with equation 3? We substitute into where? Where do we substitute? Do we substitute 1, 2? No, we do not substitute into 1. We substitute into 2. We substitute equation 3 into equation 2. The way that will work is it will return a formula that tells us that we substitute in x, remember, because we have isolated x. So we substitute in x. Wherever we see an x, we put in 3 minus y. Therefore, we have 3 minus y squared plus y squared being equal to 17. From here, we expand our brackets for 3y out, 3 minus y out, sorry, plus y squared equal to 17. This gives us, remember, FOIL method. FOIL method, first outer, inner, then last. So that's going to give us 9 minus 3y minus 3y plus y squared is equals to 17. Taking this 17 to the left hand side, and collecting like terms, we find ourselves with y squared minus 6y plus 9 minus 17 equals to 0. 9 minus 17 is equals to 8. Negative 8. From here, oh sorry, this must be 2y. From here you can clearly see that 2 is a common factor, so you can divide by it. You can divide by 2, and 0 over 2 is just 2, though thus you are left with y minus 6y. Sorry, not y minus 6y, it's y minus 3y. Minus 3y minus 8 being minus 4 being equal to 0. Now, you ask yourself again, what factors of 1, remember that there is a coefficient of 1 there, what factors of 1 and 4 will return 3? And obviously that's going to be a minus 4 and a positive 1. Thus you have y minus 4 y plus 1, which is equal to 0. Your y will then be equal to 4, or your y will be equal to 1. For y equal to 4, we sub into 1. Do the same for y equal to 1, right? Now I'll just do that to separate out the two cases. So for y into 4, for y is equals to 4, we have that x is equals to 3 minus y, which is equals to 3 minus 4 minus 1. This side you have that x is equals to 3 minus y, which is equals to 3 minus 1. Sorry, that was supposed to be a negative 1. Yeah, that was supposed to be a negative 1. So now what happens now? This is equal to 4. So I hope that made sense. This is quite the easy simultaneous equation, so it shouldn't be that difficult to grasp. Finally, let us go through 1.3. So 1.3 may be a bit of a tricky one because it's not always clear what you do with such an expression, but we will simplify as far as we can. Now we have, let me look at the question. What does the question say? Okay, we have that we must determine without the use of a calculator the value of all of that, right? How are we going to do that? How are we going to do that? Let me just write it out real quick. 1 over square root of 2. It's 1 over square root of 1 plus square root of 2 plus 1 over square root of 2 plus square root of 3 plus 1 over square root of 4 plus square root of 5 plus 1 over square root of 99 plus square root of 100. Now the way we're going to do this is we are first going to look for a term that can rationalize our expression while keeping it the same. And in case of the first term, in order to rationalize, what we are going to do is we are going to multiply by 1. And let me show you what I mean when I say multiply by 1. We are going to take this to be 1 over square root of 1 plus square root of 2 multiplied by square root of 1 minus the square root of 2 over square root of 1 minus the square root of 2. So since the denominator and the numerator are exactly equal, this essentially just tells us immediately that this is 1 and our expression hasn't changed. So we will do that for all the terms. Root 2 plus root 3 multiplied by root 2 minus root 3, root 2 minus root 3, sorry about that, root 3 plus 1 over root 4 plus root 5 multiplied by root 4 minus root 5 over root 4 minus root 5 plus dot 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 plus, let's write a dot there, 1 over root 99 plus root 100 multiplied by root 99 minus root 100 over root 99 minus root 100. So now here's the trick. The trick is these two operate, or they come across as a difference of two squares. If you look at the objects in the denominators, they come across as differences of squares. So since they are differences of squares, you're going to have, say for the first one, you're going to have square root of 1 into square root of 1 minus square root of 1 into negative square root, oh no, this should, I already minus, this should be square root of 2 plus square root of 2 into square root of 1 minus square root of 2 into square root of 2, which is going to be essentially 1. These two cancel each other out, minus square root of 4, which is essentially just going to be 1 minus 2, right? But all of this is unnecessary, because if you work it all out, it will eventually simplify to minus 1 plus square root of 2, right? Because remember that 1 minus 4, here it is, plus square root of 2 minus square root of 2, right? Plus square root of 3 minus square root of 3 plus, right? And then this becomes a minus square root of 99. Okay, let's make that a plus square root of 99 minus square root of 99 plus square root of 100, which is essentially just 10. So if you look at the way that the sequence or this expression is progressing, it essentially tells you that every term in the sequence other than the minus 1 and the 10 cancel each other out, because you see that it returns a positive minus 2 positive and a negative 2 square root of 2. It's going to do the same thing for the square root of 31. It's going to return the square root of negative 31 and the negative square root of 31 and the positive square root of 31, which are essentially going to cancel each other out, and at the end of the day the final answer will be equal to 9. So thank you very much for joining me today as we went through paper 1 of the grade 11 mathematics May-June 2023 exam. We are concluding this video for question 1, and I will see you next time.